Alright, in this video we're going to continue working examples using the rational zero test. Most notably we're going to work some examples where the leading coefficient is not 1. So let's start with an example. Let's find the rational zeros of 2x cubed plus 3x squared minus 8x plus 3. Again, similar to the last video in the second example, the U-try example, grouping's not going to get us anywhere, so we really just need to start trying to guess some zeros. So let's see here. We have that. What could P be for a rational zero? Well, it could be P could be plus or minus 1 or plus or minus 3. Q could be plus or minus 1 or plus or minus 2. And this gives us several possible rational zeros then. P over Q could then be 1 or negative 1, 3 or negative 3, and then putting everything over, putting each of those over 1, putting each of them over 2 would give us 1/2 or negative 1/2, and 3/2 or negative 3/2. That's positive 3/2. And again, I write them this way because that shows us that we have 4 possible rational zeros. Of course, 8 possible rational zeros. Of course, we know they can't all possibly be zeros of this because of the fact that this is only a polynomial of degree 3, so it has 3 zeros. So let's go through and look at this. If we try testing some of these zeros, let's just go through and look. If we try f of negative 1, f of 1, what do we get? We would get 2 plus 3 minus 8 plus 3. Hey, look at that. That's a 0. Trying out, yeah, 1 actually gave us a 0 first try. Isn't that nice? Well then, because that's the case, you could keep trying more zeros. However, we notice that that means that x minus 1 is a factor, which means we can factor it out and get a quadratic. And we can always solve quadratics to find the remaining zeros and see which ones are rational. So let's go through and do that. If we plug, so we would have 1, we have 2, 3, negative 8, and 3. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 8 plus 5 is negative 3. 1 times negative 3 is negative 3. And 3 plus negative 3 is 0, which works. So we now have as our remainder, as our quotient, 2x squared plus 5x minus 3. The zeros of that, we can use the quadratic formula. X equals negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3. Looking here, you'll see the negative will be a positive, so this actually gives a, this is not going to be a complex 0. 2 times 2. And thus we end up with negative 5 plus or minus the square root of 25 plus 4 times 2 is 8. 8 times 3 is 8 times 3 is 24 all over 4, which gives us here, that would be 49, which is a perfect square, so 7, negative 5 plus or minus 7 over 4, which gives 2 possibilities. If we add the 7, then we would get 2 over 4, which would be 1/2. If we subtract the 7, then we get negative 12 over 4, which would be negative 3. In other words, we actually have 3 rational zeros. For the first time, all of our zeros are rational. X equal 1 is a rational zero, which we found at the start. Then we found 1/2 and 3. And notice all of these are both on our list, right? So we actually did have that this, and this were all our rational zeros. So now it's time for you to try an example. Go ahead and find the rational zeros of f of x equals 2x cubed plus x squared minus 13x plus 6. On the count of 3, I'll reveal the solution. 1, 2, 3. So here, plugging in, we get all of our list of rational zeros. Plugging them all in, we get that x equal 2 is 1. We have 1 here. We have 1/2 is 1, and we have -3 is 1. Another thing you could do, and I didn't want to go through all the steps to do it, but you could, once you find one of them, you could divide out by it. That would give you a quadratic then, and then you can always factor that you can always solve that quadratic for the other two. And sort of those alternative approaches are useful because in general we know that because of square roots, for example, not all zeros will be rational. Still though, we know that this provides a useful starting point for finding zeros, as we saw in the last few examples, because then we have a chance of getting rid of a zero, and then we can go ahead and divide out and then try to get a quadratic to find the rest of them. So let's do an example of that. So first, let's start trying to find a rational zero to divide out by. Our list of possibilities are x equal negative what? X equal p, sorry. What can p be? P could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Q could be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Of course, not all of these can be zeros, but by going through and checking, you can find that, give me a moment, you will find that negative x equal 2 is, x equal 2 actually gives a 0, so if you plug 2 in, you will actually get 0 back out, okay? Yeah, because that's negative 80 plus 60, which is negative 20. Negative 20 plus 32 is positive 12, minus 12 is 0. Yeah, so good. Well, if f of 2 equals 0, that means x minus 2 is a factor. In other words, we should be able to do some synthetic division. So we have that dividing out by 2. Our coefficients are negative 10, 15, 16, and negative 12. Then negative 10 comes down, negative 20, negative 5, negative 10, positive 6, positive 12, 0. Haha. So, using that, we now know that what we have left is negative 10x squared minus 5x plus 6 equals 0. In other words, we now can use the quadratic formula. We have x equals negative 5 plus or minus the square root of b squared, which is 25, minus 4 times a, which is negative 10, times c, which is 6, all over 2 times negative 10. We have 5 plus or minus square root of 240 plus 25. So, yeah, 4 times 6 is 24, 240 plus 25 is 265. All over negative 20. Reducing that down, 265, well, square root of 265 is not a nice number. What we have, though, is you'll get so you can't actually, 265, it doesn't reduce down, because 265 divided by 5 is 53, so this doesn't reduce down any. this tells you that these are our only other two solutions. So our zeros are 2, 5 plus square root 265 over negative 20, and 5 minus square root of 265 over negative 20. And those would be our solutions. And now it's time for you to try a problem. So go ahead and find all real solutions of the following equation. On the count of 3, I'll reveal the solution. 1, 2, 3. So you get your P's and Q's before, then by doing that you get this long list of zeros. Plugging in various zeros, and it took me a while to get this, sadly, because I kind of plugged in I plugged in 1, 2, 3, 6, 9, negative 9, negative 6, negative 3, negative 2, and then I finally plugged in negative 1 and got a 0. Huzzah! Once I got the 0 out, I can divide out by it, and then I end up with a quadratic. Well, quadratics are easy to solve for the zeros. You just go ahead and use the quadratic formula, and then it's a simple matter of just writing down the zeros. For more practice and working with the rational zero theorem, be sure to see pages 162 and 163 of the textbook and work problems 25 through 36. In our next video, we'll talk about how to use conjugate pairs to find zeros as well.